Hello and welcome. In this video, we're going to be discussing how to graph a solution to a system of linear inequalities. So if you didn't watch the video on graphing linear inequalities, I would strongly suggest that you do that before viewing this video. So what does it mean to solve a system of either equations or inequalities? Well, solving a system means that we want to find solutions that are common to all of those equations or inequalities within the system. So that's what we're going to be doing here. We're going to be trying to find solutions that are common to both of these inequalities. So our first step in doing that is let's find the solutions for each inequality separately. So the way that we're going to do that basically comes down to graphing out each one of these linear inequalities separately. So the way that we did that in the previous video is we started with the analogous equation. So the first one, we started by graphing out y equals negative 3x plus 5, and then shading the appropriate side. And then for the second one, which we're going to do in green, again we started by graphing out the solutions to y equals 3x minus 7, and then shading the appropriate side. So here we go. If we graph out y equals negative 3x plus 5, the y-intercept is at 5. The slope is telling us to go down 3 and over 1. And then notice that in the original inequality, we just have less than, we don't have equal to. So I'm going to draw the line as a dashed line. And then in terms of plotting out that green equation, we've got y equals 3x minus 7, so I'm going to start at my y-intercept of negative 7, and then the slope is up 3 and over 1, 1, 2, 3 over 1. And notice that one is going to be a solid line because I am allowed to be equal to here. So when we plot that line out, we'll have something that looks like this. Okay. Now, to find which side of each line I'm supposed to shade, this is where I picked a test point. So one of the things to note is that 0, 0 is a point that's not on either one of either the red or the green line. So I can use that as a test point like I did in the last video. So I'm going to write our inequality, our original inequality for each one. And then I'm going to test 0, 0 to see if that gives me a true or false statement. So I'm going to plug 0 in for x, 0 in for y. If I do that, I'll get 0 is less than negative 3 times 0 plus 5. If I work out the right-hand side, I get 0 is less than negative 3 times 0 is 0 plus 5 is 5. That's a true statement. Okay, let's do the green one right away. So I want to test 0, 0 again. So plug 0 in for x, 0 in for y. We get 0 is greater than or equal to 3 times 0 minus 7. If I work out the right-hand side, I just get 7. That again, negative 7. That again is a true statement. So that means for both the red and the green inequalities, I want to shade the side that includes the point 0, 0. So this point right here. So if I do the red would include basically this whole section. And if I do the green would include the side again that contains the point 0, 0. So it would be this whole section. So what's the solution? Well, you can see that in that mess, there's a part where the red and the green areas overlap each other. Where is that section? Well, I'm going to try to do it in blue so that we can see it. So there's this point of intersection right over here, and then the intersected area follows this green line down. We've got this dashed line, this dashed red line up, and then it's really this area in between the solid green line and the dashed red line. So that whole area in blue would be the solutions that are common to both of those inequalities. That would be the solution to my system. Okay, here's another one for you to try. Pause the video and then restart after you've given it a shot. Okay, so if we start by just plotting out each one of those inequalities, again I'm going to do the top one in red, the bottom one in green, and I want to start just by plotting both equations. So we've got, for the red one, 3x minus 5, so I want to start at negative 5. Slope is telling me go up 3 and over 1. And then if I look at the original inequality, it's just less than, so I want to do a dashed line here. The green guy, we've got a y-intercept of 3. And then the slope is telling me to go down 4 and over 1. So if I do that, and then again if I look at the original, notice that it's greater than, not greater than or equal to, so I want to do a dashed line here. And then again, 0, 0 is a point that's not on either line, so I'm going to use that as a test point in each one. So if I write down my inequality, I've got y is less than 3x minus 5. Y is greater than negative 4x plus 3. And then if we do 0, 0 as a test, plug 0 in for x, plug 0 in for y, we get 0 is less than 3 times 0 minus 5, so 0 is less than negative 5. That's false. Okay, so that means for the red guy, I don't want to shade the side of the side of that red line that contains the point 0, 0. So for my red guy, I would want to shade basically all of this section. For the green guy, again, I want to test 0, 0. So if I plug 0 in for y, plug 0 in for x, I get 0 is greater than 3. That's a false statement as well. So that means for the green guy, I don't want to shade the side that contains the point 0, 0. So for the green guy, I want to shade this side instead. And then I'm looking for the overlap between the two. Well, the overlap, if I first trace out the boundaries in blue, it would be that red and the green line, at least the portions of those red and green lines, and then it would be this area in the middle. And that would be my solution.